Scholars, how are we doing, my little scientific scholars? Today is an absolutely wonderful day. I know that you are having a great day. I'm having a great day. And today we're going to have a great day talking about great scientific things. And what is the scientific thing that we are going to talk about today? It's going to be our mixtures. Yes, so now we've been talking about mixtures. We've been talking about mixtures is one of the physical properties that we can use to classify matter into groups. We're breaking it into groups, we're breaking it into groups, we're breaking it into groups. And we learned that mixtures are two or more things that when we put them together, they maintain their physical properties. And because of that, they are easily separated. They maintain their physical properties. And because of that, they are easily separated. We talked about a couple of mixtures, like if I have a bag and it has a whole bunch of random items in it, I can reach off into this mixture of items and I can pull out the plastic straw. The plastic did not all of a sudden become wood because I have a popsicle stick off in here. The popsicle stick did not become the plastic because I have plastic in here. It didn't change. Why? Because they maintain their physical properties. The wood is not as flexible. Plastic is going to have a little bit of flexibility. I see that this is white, this is brown, and just because I stick them in a bag together, it does not change their physical properties, and therefore it makes it where they are very easily separated. Another mixture that we saw that was really cool was the iron fillings and sand. So we take this and we have our little magnet like we showed before, and I can grab it and I can stick it all off in there. We get a nice little shake going on. And then if I flip it over, I can see at the top of the bag are all of the iron filings. And if I remove it, we see them fall because the iron filings are magnetic. One of their physical properties is they are magnetic. And I can use this magnet as a tool to separate them because I understand their physical properties. But mixtures don't always just involve solids. Sometimes mixtures can actually involve liquids. So off in this, I have some rocks that we can see. And I can take these rocks and I can have a mixture of rocks and water. Now remember our physical properties of our definition of a mixture is two or more things put together where they are easily separated because they maintain their physical properties. Is this a mixture? Do we see two or more things put together? Yes. Are these easily separatable? Let's check it out. I can reach right in, pull my rocks right out. My rocks are the same size, they're the same color, they're still very hard, they haven't changed shape. My water is still a liquid. Nothing has changed about their physical properties. This, ladies and gentlemen, is definitely a mixture. But it goes even further than that because mixtures can also be between two liquids. So I'm going to take my cup here and I'm going to fill this with water. Now, if I was to put some vegetable oil off in there, what do you think is going to happen? What will we classify this as? Will it still be a mixture? Will it change to something else? What do you think? Because we're about to do it right now. It's going down for real. We are learning about these mixtures. I have my vegetable oil. I have my liquid that's water. Both of these are liquids. Both of them take the shape of their containers. Both of them have a definite volume. And we are coming together in 3, 2, 1, and go. Oh, do you see it? Like a little child. Do you see it? Do you see it? What do you notice at the top of the water? Right here on this brim. I hope that you notice, oh, you can see it really good from right there, that the vegetable oil, here's an old lesson, is less dense, or it floats on top of the water. Its density is less, so it floats on top of the water. Therefore, I could skim this off the top of the water because it's a mixture. Yes, this is actually the same science that we use whenever there's an oil spill. Whenever there's an oil spill, we have these boats that go and they skim the oil off the top of the water because, once again, understanding density helps us to separate those types of objects. Physical properties are so important because when we understand these physical properties, there's so much that we can do in science. But guess what? There's more to mixtures than just solids with solids. there's more to mixtures than just liquids with solids. And sometimes liquids and solids, they have different interactions when they interact. So there's another kind of mixture that we haven't talked about. I know. You've been waiting for it. I've been waiting for it. I wanted to tell you. I'm so glad that you asked. There's another kind of mixture. Thank you so much for asking. What is the mixture called, Mr. Washington? Yes, I will tell you because y'all are awesome. This mixture is called a solution. Now, a solution is a special kind of mixture, right? So it's two things put together. It's a special kind of mixture where one object dissolves in another. And you've all seen it before. Every single one of us has seen it before because we've all had something, some solid, where when we put it off into water, we have noticed that it dissolved in the water. A great example of that is food coloring. So if I was to take some more water and I stick it off in here and I have my red food coloring, I can take it. I can do my drops. Here we go. 1, 2, 3. And then I notice that it's not operating like the vegetable oil did. It's very differently. This is actually dispersing throughout the water. You see it? And I can actually speed that process up if I take my finger and I begin to mix it up. And I notice that all of the water is now turning red. That is very, very different than the vegetable oil. When we had the vegetable oil, we'll notice that it just sat right on the top. So this is a mixture, but this is a special kind of mixture that we call a solution where one object dissolves in another, right? That is our lesson for today. We have learned about solutions and we understand that solutions are a special kind of mixture where one object dissolves into another. Today, what I want you to do is I want you to do a Frayer model. What is a Frayer model? Frayer model is where we stick the word in the center and it's got the word blocks where you give me the definition, you give me an example, you can use it in a sentence, and you can draw a picture. And I want you to tell me, what does the word solution mean to you? What does the word solution mean to you? Based on everything that we saw today, what is a solution? Feel free to use Google. Google is our best friend when we're looking things up. And have an absolutely wonderful, amazing, scientific day. And we will be back soon with more science. And we'll continue to talk about this thing that we call solutions.